Every image of the Milky Way you have ever seen is misleading, not because the images are false, but because your brain automatically shrinks what it is looking at into something survivable. A spiral galaxy appears elegant from a distance, calm, structured, almost understandable. A soft band of light stretched across blackness, billions of stars arranged into graceful rotating arms, something the human mind can place into a category, a place. But the real Milky Way is not a place in the way human beings evolved to understand places. It is not a continent waiting to be crossed, not an ocean waiting to be sailed, not even a solar system waiting to be explored. It is a structure so large that human civilization emerged and evolved entirely inside a microscopic corner of it, without ever noticing the larger shape surrounding us. Tonight, as you sit beneath the night sky, the galaxy already contains distances that no human being may ever survive crossing, and the terrifying part is not how far away the stars are, it is how slowly reality allows movement between them. Light itself struggles inside the Milky Way. A beam leaving one side of the galaxy requires roughly 100,000 years to reach the other. When that journey began, early humans were still sharing the Earth with mammoths. Entire civilizations had not yet formed. Agriculture did not yet exist. Language itself was still primitive, and yet the light is still travelling. The Milky Way is so enormous that even the fastest thing the universe permits cannot cross it within the lifespan of a species. Human intuition has no framework for this. Our ancestors evolved to think in forests, rivers, mountains, coastlines, distances measured in footsteps and horizons. Even modern civilization still thinks geographically. We speak about Mars as though it is nearby because radio signals only require minutes to arrive there. But the nearest star beyond our sun is so distant that every human who has ever lived could fit inside the time required merely for a spacecraft to approach it using present-day technology. And that is only the nearest star. The galaxy contains somewhere between 100 and 400 billion of them. Most are separated by gulfs of darkness so vast that the emptiness itself becomes the dominant feature of reality. This is where the comforting vision of humanity spreading endlessly through the cosmos begins to fracture. Science fiction often treats the galaxy as crowded, traversable, alive with movement, ships crossing between stars as aircraft cross oceans, civilizations expanding outward forever. But the real Milky Way obeys physics. And physics is far less forgiving than imagination. There are no hidden shortcuts confirmed by science. No faster-than-light engines. No evidence that space can be crossed quickly enough for the galaxy to become emotionally manageable. Instead, modern physics keeps delivering the same quiet message over and over again. The universe is not designed for travel, at least not for creatures like us. Even now, the fastest human-made object ever constructed would require tens of thousands of years to reach another star system. Not cross the galaxy, not reach its centre, merely approach one neighbouring point of light. A journey longer than recorded history, longer than civilization, longer than memory, and during that unimaginable drift through darkness, the galaxy itself would continue moving, stars orbiting the galactic centre, nebulae collapsing, solar systems forming and dying, entire constellations rearranging themselves while the travellers remain trapped between suns. Because the Milky Way is not static. It is rotating. Everything inside it is falling through space together, around an invisible centre, dominated by a supermassive black hole 4 million times heavier than the Sun. Our own solar system is currently moving through the galaxy at roughly 828,000 kilometers per hour. And yet even at that speed, one complete orbit around the Milky Way requires around 230 million years. The last time Earth occupied this position in the galaxy, dinosaurs had not yet vanished. That is the scale we already inhabit. Not a future scale, not a distant abstraction. This one, right now. Human beings often imagine escape as a technological problem. Build better engines, larger ships, smarter machines. But what if the deeper problem is scale itself? What if the Milky Way is not merely difficult to cross, but functionally impossible for biological civilizations? What if intelligence naturally emerges inside galaxies while remaining permanently trapped within tiny isolated pockets of them? Small islands of warmth surrounded by distances too immense for meaningful migration. What if every civilization eventually discovers the same terrible truth, that the galaxy looks open only because the human brain cannot emotionally process the size of the cage? And the real discomfort begins here, because once scale expands beyond intuition, hope begins shrinking with it. The Milky Way stops feeling like a frontier and starts feeling like an ocean without shores. For most of human history, the galaxy felt close. Not physically close, of course. The stars were always unreachable, but psychologically close. Ancient people looked upward and saw patterns, not distance. Constellations became hunters, rivers, kings, animals, gods. The night sky felt intimate because the human mind transformed light into mythology before it ever confronted scale. Even after science replaced myth, the emotional illusion remained. The Milky Way became a map, and maps create confidence once something can be diagrammed, labelled, divided into regions and structures. The brain quietly assumes it can eventually be navigated. Schoolbooks displayed spiral galaxies from above, flattening incomprehensible depth into graceful shapes no larger than a page. Science fiction strengthened the illusion further. Worlds connected by roots, empires spanning sectors, humanity expanding outward naturally, as though the stars were merely distant continents waiting for ships. The galaxy became familiar long before it became understood. And this misunderstanding runs deeper than most people realize, because human beings evolved in environments where distance usually implied possibility. A mountain beyond the horizon could eventually be climbed. An ocean could eventually be crossed. Even Antarctica, once unimaginably remote, slowly surrendered to engineering and persistence. Every frontier in human history carried the same hidden psychological lesson. Difficult does not mean impossible. Civilization inherited this assumption so completely that many people unconsciously apply it to the cosmos itself. If the stars exist, we imagine we will someday reach them. If enough time passes, humanity spreads. If technology advances, the galaxy opens. But this confidence emerged from life on a small planet where the laws of physics rarely reveal their full severity. Earth is unusually forgiving. The atmosphere protects fragile biology from radiation. Gravity is gentle enough for bodies to move efficiently. Temperatures remain narrow enough for liquid water. Communication happens nearly instantly across continents. Even the vacuum of space lies only a few hundred kilometers overhead, creating the illusion that the universe begins just beyond our reach. Yet the moment humans moved outward, reality changed violently. The moon already exposed part of the deception. In photographs, it appears nearby, a companion world hanging softly above Earth every night. But during the Apollo missions, astronauts traveled through nearly 4 days of empty space merely to reach it. Every second of the journey unfolded inside lethal vacuum. Outside, the thin walls of the spacecraft waited radiation, micrometeoroids, solar exposure, and temperatures capable of freezing or boiling matter depending on orientation to sunlight. And the moon is still inside Earth's immediate neighborhood. On cosmic scales, it is touching us. Mars feels farther away emotionally, but still exists within the tiny warm bubble surrounding our sun. Radio messages between Earth and Mars can require over 20 minutes one way depending on orbital positions. A conversation becomes impossible. Every command arrives delayed. Every emergency unfolds in silence before help can even respond. Already, distance begins eroding civilization itself. Not through violence, through delay, because human society depends upon synchronization, shared time, shared communication, shared memory moving fast enough to preserve coherence between people. The larger the distance becomes, the more reality separates communities into isolated worlds. And interstellar space expands this separation beyond anything human beings evolved to endure. Consider the Voyager 1 spacecraft. Launched in 1977, it travelled past the outer planets and continued outward into interstellar space. Even after nearly half a century of uninterrupted motion, Voyager 1 has only moved about one light day away from Earth. One day. Light requires an entire day merely to travel the distance Voyager crossed in almost 50 years. Yet the nearest star system, Alpha Centauri, is over 4 light-years away. Not 4 years by spacecraft, 4 years by light itself. Voyager would need more than 70,000 years to arrive there. 70,000 years ago, Neanderthals still walked portions of Earth. Human civilization did not exist. Written language did not exist. Every government, religion, border, economy, an institution currently alive would vanish long before such a probe reached even the nearest stellar destination, and Voyager is among the fastest objects humanity has ever built. This is where ordinary intuition quietly fails. The galaxy appears traversable because humans naturally compress large scales emotionally. Numbers alone do not trigger understanding. 1 billion kilometers and 1 billion light-years both become abstractions. The brain stores them in the same vague category very far. But space does not care about emotional compression. Physics preserves the true scale. The Milky Way contains stars separated by distances so enormous that even successful interstellar travel may never create a connected civilization. Colonies would drift beyond communication. Messages would arrive centuries or millennia after they were sent. Entire societies would evolve independently between exchanges of information. The galaxy would not behave like a nation, or even a planet. It would behave like isolated fragments of history scattered across deep time. And this is assuming travel itself becomes possible, because propulsion presents another quiet catastrophe. Chemical rockets, the machines that carried humans to the moon, are almost useless for interstellar journeys. They simply do not carry enough energy efficiently enough. To reach even a modest fraction of light speed would require propulsion systems far beyond current engineering capabilities. Nuclear fusion concepts, antimatter theories, laser sails all remain speculative, partial, or massively impractical. The deeper physics becomes, the more hostile movement appears. Relativity introduces limits that no civilization has ever been observed overcoming. Mass resists acceleration. Energy demands grow catastrophically. Time itself behaves differently at extreme velocities. Even hypothetical generation ships would become drifting artificial worlds, requiring extraordinary stability over thousands of years. And stability may be rarer than intelligence. Human history already demonstrates how fragile civilizations truly are. Empires collapse within centuries. Languages mutate rapidly. Political systems decay. Ecological systems destabilize. Technologies disappear. Entire cultures vanish. Now stretch that instability across 10,000 years inside a sealed machine crossing interstellar darkness. The problem ceases to resemble exploration. It begins resembling survival against reality itself. What most people never realize is that humanity has never solved a single challenge remotely comparable to this scale. Every triumph in exploration occurred inside one tiny gravitational system dominated by one nearby star. The solar system feels enormous to us only because we were born so small. But the sun itself is merely one ordinary star among hundreds of billions inside a galaxy already so vast that its true dimensions resist comprehension. And somewhere inside this growing realization, a subtle emotional reversal begins. The stars stop feeling nearby. The galaxy stops feeling available. And the night sky slowly transforms from an invitation into evidence of separation. The first true shock arrives when the human mind finally attempts to understand what a star actually is. Not visually, not symbolically, but physically. For most people, stars remain emotionally equivalent to distant lights. Even after learning basic astronomy, the intuition persists. A star feels like an object sitting far away in darkness, something comparable to a planet or a glowing point suspended in space. But the nearest star beyond our Sun immediately destroys this illusion. Alpha Centauri is not a point in the sky. It is an entire stellar system separated from us by approximately 40 trillion kilometers. And despite that unimaginable distance, it is still considered our cosmic neighbor. The light currently entering your eyes from Alpha Centauri left before some children now alive were born. Every photon spent more than 4 years crossing pure vacuum before reaching Earth. Nothing slowed it down. Nothing delayed it. It travelled at the maximum speed permitted by reality itself. And still it required years. This is where scale begins destabilizing intuition in a more dangerous way. Because human beings evolved to think about movement through environments filled with resistance. Walking, sailing, driving, flying all involve friction, terrain, weather, obstacles, but light moves through empty space faster than anything else physically can. There is no hidden reserve beyond it, no secret higher speed waiting for technological maturity. Light is not merely fast, it is the speed limit built into causality itself. Which means every interstellar distance carries a built-in minimum travel time that cannot simply be engineered away. Even if humanity constructed a ship capable of moving at 10% the speed of light far beyond anything remotely achievable today, the journey to Alpha Centauri would still require over 40 years from Earth's perspective, an entire human lifetime merely to reach the nearest star. And at those velocities, the environment of interstellar space itself becomes lethal. Empty space is not truly empty. This misconception survives because vacuum appears peaceful in images. Blackness suggests absence. Silence suggests stillness. But between the stars exists a thin scattering of hydrogen atoms, dust grains, cosmic rays, magnetic fields, and high-energy particles moving through this galaxy at enormous velocities. Under ordinary conditions, these particles are sparse enough to seem harmless. At relativistic speeds, they become bullets. A grain of dust striking a spacecraft traveling near light speed would release energy comparable to explosives. Radiation exposure would accumulate continuously across decades. Shielding requirements would grow massive. The energy needed to accelerate and protect such a vessel would become almost incomprehensible. And all of this applies only to reaching the nearest stars. The Milky Way itself extends roughly 100,000 light-years across. Human intuition cannot survive this comparison intact. Imagine compressing the solar system so that Earth's orbit becomes the width of a coin. On that scale, the nearest star would still be thousands of kilometers away. Entire countries would fit comfortably into the emptiness between neighboring stellar systems. The galaxy is not crowded. It only appears crowded because human eyes cannot resolve true depth at cosmic distances. When you look upward into the dense band of the Milky Way, your brain interprets concentration. It sees accumulation, a river of stars packed tightly together. But much of what you're seeing is perspective. The galactic disk contains enormous volumes of near-total emptiness. Stars rarely approach each other closely. If our sun were reduced to the size of a grain of sand, the nearest comparable grain might still lie hundreds of kilometers away. Civilization evolved inside emptiness so vast that most of the galaxy is functionally unoccupied. And yet even this picture remains incomplete. Because stars themselves are moving, nothing in the galaxy stays fixed long enough for stable maps to retain meaning across deep time. Every star orbits the galactic center according to its own velocity and gravitational interactions. Over millions of years, constellations distort beyond recognition. Neighboring stars drift elsewhere. Entire regions of the sky rearrange themselves slowly and continuously. The night sky humans inherited is temporary. Even the stars surrounding Earth today are only passing companions. 5 million years from now, the familiar constellations of modern humanity will no longer exist in recognizable form. Orion will dissolve. The Big Dipper will distort. New stars will emerge while others vanish below the horizon forever. The galaxy behaves less like architecture and more like weather unfolding across incomprehensible time. What most people never realize is that the Sun itself is already traveling through the Milky Way at extraordinary speed. Solar orbit. Around the galactic center carries our entire solar system around the galactic center once every 230 million years. Dinosaurs lived during the last galactic year. Since then, continents shifted, species evolved, extinction events unfolded, mammals emerged, primates appeared, and human civilization flickered briefly into existence. All while the solar system completed only a tiny fraction of one orbit. The galaxy moves on timescales so large that biology itself becomes temporary inside its motion. And this creates a profound problem for any civilization attempting interstellar expansion. Destinations refuse to remain stationary. A voyage lasting thousands of years would not simply involve traveling toward a fixed target. The target itself would continue moving through the galaxy simultaneously. Gravitational conditions would evolve. Stellar encounters would alter trajectories. Radiation environments could shift unpredictably. The Milky Way is dynamic, restless, alive with slow gravitational turbulence. Even communication becomes strange under these conditions. Suppose humanity eventually establishes a colony 100 light-years away. Every message exchange between Earth and that colony requires centuries for a complete conversation cycle. A child born after sending a greeting would die long before receiving a reply. Eventually, synchronized civilization becomes impossible. History fragments. Identity diverges. Humanity ceases behaving as one species psychologically, even if biology remains similar. And at larger scales, separation deepens further into something colder. Because galaxies do not merely contain distance, they contain delayed reality. When astronomers observe distant regions of the Milky Way, they're not seeing the galaxy as it is now. They're seeing layered moments from different eras simultaneously. Some stars appear as they existed thousands of years ago, others tens of thousands. The galactic center visible in infrared telescopes belongs partly to an ancient past relative to Earth. No observer inside a galaxy ever sees the galaxy in one unified present moment. The Milky Way is too large for simultaneity. Even light cannot fully connect it in real time. And somewhere inside this realization, the emotional texture of the cosmos changes again. The galaxy stops feeling like a structure humanity has not yet explored, and begins feeling like a system fundamentally incompatible with the speed of human life. A place where even light arrives late. Human beings instinctively imagine progress as acceleration. Faster ships, faster communication, faster discovery. The entire psychological structure of civilization quietly assumes that difficult barriers eventually collapse beneath technological momentum. History appears to support this belief. Travel that once required months now requires hours. Information that once moved at the speed of horses now crosses continents instantly. Each century compresses distance further, and because of this pattern, many people unconsciously assume the stars represent merely another engineering problem waiting for maturity. But this is where the picture begins to break down, because interstellar space is not simply a larger version of terrestrial exploration. It belongs to an entirely different category of reality. The difference is not quantitative, it is structural. The laws governing the cosmos contain limits that do not negotiate with ambition. And nowhere is this more disturbing than in the quiet implications of relativity. Albert Einstein did not merely change physics, he changed the emotional geometry of the universe. Before relativity, many scientists imagined that speed could increase indefinitely. Faster engines would eventually produce arbitrarily rapid travel. Space seemed open in principle. Even if difficult in practice, relativity destroyed this comfort. According to modern physics, accelerating an object with mass requires increasing amounts of energy the closer it approaches light speed. The relationship is not linear. Energy demands rise catastrophically. To actually reach the speed of light would require infinite energy. Infinite. Not impractical, not difficult, physically impossible. This is not an engineering limitation. It is embedded into space-time itself, and the implications are psychologically devastating once scale enters the equation. At ordinary human velocities, the universe feels manageable because our experiences occur inside tiny pockets of space and time. Walking across a room or flying across an ocean barely registers against relativistic effects. Reality appears stable and intuitive, but the galaxy exists on scales where intuition fails completely. Suppose humanity somehow constructs an advanced spacecraft capable of reaching 10% of light speed. Such a machine would already represent technology almost beyond present comprehension. The kinetic energy alone involved in accelerating a large vessel to that velocity would rival planetary-scale energy consumption. Yet even then, the Milky Way remains effectively unconquered. At 10% light speed, crossing the galaxy would require roughly 1 million years. Not from the perspective of the travellers alone. From Earth's perspective, 1 million years ago, human beings did not yet exist in modern form. Fire had not been mastered consistently. No cities existed. No language survives from anywhere near that depth of time because language itself had barely emerged. A civilization beginning such a voyage would vanish into prehistory before arriving. And the real problem is even stranger. Because relativity introduces a fracture between objective time and experienced time. As velocities approach light speed, time slows for the travellers relative to observers remaining behind. This phenomenon, known as time dilation, has been experimentally confirmed countless times. Atomic clocks aboard aircraft tick differently from clocks on Earth. Particles accelerated in laboratories survive longer because time itself changes relative to motion. Reality does not maintain universal time. The universe contains many simultaneous clocks unfolding at different rates. At first glance, this appears hopeful. Perhaps travellers could reach distant stars within their own lifetimes, while centuries pass on Earth. And theoretically, this is partly true. Near-light-speed journeys compress experienced time aboard the vessel, but the emotional consequences become haunting. Imagine leaving Earth aboard a relativistic spacecraft. For you, perhaps only 20 years pass, but when you return, centuries or millennia have elapsed outside. Everyone you knew is gone. Languages evolved. Civilization transformed. Entire historical eras unfolded during your absence. Interstellar travel begins resembling one-way time exile. The faster humanity moves outward, the more completely it disconnects from its origin. And this assumes return journeys are even feasible. Because energy requirements remain horrifying, EK equals sign G1MC2. The relativistic kinetic energy equation reveals something deeply uncomfortable about the universe. Small increases near light speed require enormous additional energy. Pushing massive spacecraft faster and faster eventually approaches absurdity. Entire planets' worth of resources might be necessary merely to accelerate one vessel. The cosmos appears strangely resistant to movement, almost defensive, and this resistance compounds everywhere. Interstellar travellers would encounter relentless radiation exposure from cosmic rays and energetic particles moving through this galaxy. Shielding large enough to protect biological life increases spacecraft mass dramatically, which in turn increases propulsion demands. Every solution worsens another problem. Closed ecosystems present additional dangers. Human beings do not merely require oxygen and food. We require stable biospheres, microbial balance, psychological stability, functional social systems, reproduction across generations, protection from mutation, disease, equipment degradation, and cultural collapse. Now imagine preserving all of that flawlessly for centuries, or thousands of years, inside an artificial structure isolated forever between stars. The problem no longer resembles exploration. It resembles maintaining a tiny fragment of Earth against the entropy of the universe. And entropy always advances. Machines degrade. Materials fracture under radiation. Systems fail. Even information decays over sufficient timescales. Data corruption accumulates, archives disappear, knowledge fragments. Human institutions already struggle to preserve continuity across mere centuries on Earth, beneath a protective atmosphere and abundant biosphere. Deep space offers no forgiveness, no rescue, no margin. A single catastrophic failure aboard an interstellar vessel could doom generations not yet born. And perhaps most unsettling of all is the possibility that the universe may simply be too old for stable galactic civilizations to remain connected, because time itself slowly destroys synchronization. Suppose one civilization expands outward over millions of years. Some colonies advance technologically, others collapse. Some evolve biologically or digitally into unrecognizable forms. Communication delays increase continuously as expansion spreads across larger volumes of the galaxy. Eventually shared identity dissolves. Not through war, through time. The Milky Way may naturally fragment intelligence into isolated pockets, unable to maintain coherent civilization across galactic scales. In this sense, the galaxy behaves less like territory, and more like separation itself, a gravitational labyrinth where every star system drifts alone through immense darkness, carrying its own local history while the larger structure remains forever too vast for unity. And once this realization settles fully into place, another assumption quietly dies. Humanity may never become a galactic civilization in the way science fiction imagines, not because intelligence is weak, not because courage is lacking, but because the fabric of reality may fundamentally prohibit meaningful mastery of distances this large. The Milky Way is not merely difficult to cross, it may be operating on scales where the concept of crossing loses meaning entirely. There is a moment when scale becomes psychologically dangerous. Not intellectually difficult, dangerous. A threshold where the human mind can still understand the mathematics of distance while emotionally losing the ability to attach meaning to it. The Milky Way exists beyond that threshold, and nowhere does this become clearer than when we attempt to picture the galaxy from inside it. Human beings never experience the Milky Way directly as a whole structure. Every image showing a spiral galaxy floating beautifully in darkness is either another galaxy entirely, or an artistic reconstruction based on measurements collected from within our own. We are trapped inside the disk while trying to map the disk itself, like insects attempting to understand the shape of a forest while standing among trees. And the forest is enormous. Milky Way Galaxy spans roughly 100,000 light-years across, though some measurements suggest its outer structures extend even farther into darkness. Its spiral arms curve around a dense galactic center crowded with stars, dust clouds, radiation fields, ancient clusters, and violent gravitational phenomena. Our solar system resides far from the center, drifting quietly inside one minor spiral arm known as the Orion Arm. Not central, not important, not even especially remarkable, just another small region orbiting through the galaxy's outskirts. And this location has shaped human psychology more than most people realize, because the outer regions of the Milky Way are comparatively calm. Stars here are relatively spread apart. Catastrophic radiation events occur less frequently. Gravitational disturbances are milder than near the galactic core. The sky remains dark enough for stable planetary climates and biological evolution. Earth emerged inside a quieter suburb of the galaxy, but the deeper inward one travels, the stranger reality becomes. Near the galactic center, stars crowd together at densities difficult to imagine. Distances between stellar systems shrink dramatically. Radiation intensifies. Massive molecular clouds drift through the region like cosmic storms. Magnetic fields twist violently. Supernovae occur more frequently as gravity itself becomes turbulent, and at the center waits something even more unsettling. Sagittarius Asterisk contains roughly 4 million times the mass of the Sun compressed into a relatively small region of space-time. Invisible directly, It reveals itself through the motion of nearby stars whipping around empty-looking space at extraordinary speeds. Entire stars orbit something they cannot escape. The galaxy itself is partially organized around this gravitational abyss, and yet even Sagittarius at Asterisk is not the true source of psychological discomfort. The real discomfort comes from understanding how small the solar system becomes against galactic scale. Imagine shrinking the Milky Way until it fits across the continental United States. On that scale, the entire solar system would become smaller than a single cell. Not Earth, not humanity, the entire solar system. Every planet, every moon, every asteroid, every spacecraft humanity has ever launched, all compressed into something microscopic against the width of the galaxy. This is where familiar intuition collapses completely, because human civilization still behaves emotionally as though the solar system itself is vast territory. Mars missions dominate headlines. Jupiter appears unimaginably remote. Pluto feels almost mythic in its distance. Yet against the Milky Way, these are local details inside an almost invisible speck. The Voyager probes, after decades of uninterrupted travel, have barely begun leaving the Sun's immediate gravitational influence. They are still functionally inside our front yard, and this front yard already required billions of years to form. The Sun itself emerged around 4.6 billion years ago from the collapse of a molecular cloud enriched by older stars that lived and died before Earth existed. The atoms inside human bodies were forged in ancient stellar interiors long before the solar system formed. Even our chemistry belongs partly to dead stars. Human beings are local arrangements of galactic history, temporary biological patterns assembled from recycled matter drifting through one tiny region of the Milky Way. And the galaxy does not notice us. This indifference becomes harder to ignore as scale expands outward. A typical spiral arm may contain billions of stars. Entire civilizations could theoretically rise and vanish there without affecting the overall structure of the galaxy in any detectable way. Supernovae would continue exploding. Nebulae would continue collapsing into new stellar systems. Black holes would continue consuming matter. Galactic rotation would continue uninterrupted. Humanity would disappear as quietly as bacteria vanishing inside an ocean, because the Milky Way operates on scales where individual civilizations become physically insignificant, and time deepens this insignificance further. A single orbit around the galaxy takes our solar system approximately 230 million years. 230 million years? Human civilization, by comparison, occupies only a microscopic instant. Recorded history spans roughly 5,000 years. Agriculture, perhaps 12,000. Anatomically modern humans, around 300,000 years. These numbers feel ancient to us, but against galactic motion they become almost invisible. If the Milky Way's current age were compressed into one calendar year, all of recorded human history would occupy only the final seconds before midnight on December 31st. Every empire, every war, every religion, every scientific breakthrough, every language, every life, a flicker inside the final moment of the galactic year. And meanwhile the galaxy keeps moving. Stars drift continuously through spiral arms. Some migrate inward, others outward. Stellar encounters alter trajectories subtly across millions of years. Entire star clusters gradually disperse under gravitational interactions. Even spiral arms themselves may be temporary density waves rather than permanent structures. Nothing remains fixed long enough for permanence. The Milky Way is not architecture. It is flow, slow beyond comprehension, but still flowing. What most people never realize is that the galaxy also contains enormous empty regions, where stars become sparse for thousands of light years. Dark molecular clouds block visible light entirely, creating vast obscured corridors across portions of the galactic disk. Interstellar space remains unimaginably cold, often only a few degrees above absolute zero. The dominant condition of the galaxy is not life, not planets, not sunlight. It is darkness. Cold darkness interrupted occasionally by isolated islands of fusion, And those islands themselves are temporary. Stars die, some gently fade into white dwarfs, others explode violently as supernovae, sterilizing nearby systems with radiation bursts powerful enough to reshape entire regions of space. Massive stars burn quickly and vanish. Even stable stars like the Sun possess finite lifespans measured in billions of years. The Milky Way is filled with graveyards of extinct suns. Some planetary systems likely formed and disappeared before Earth even existed. Others are forming now around newborn stars hidden inside dense nebulae. Humanity cannot yet observe clearly. The galaxy contains layers of time unfolding simultaneously. Ancient stars, young stars, dead stars, worlds still cooling from formation, worlds already frozen forever. And somewhere inside this immense rotating structure, human beings continue imagining escape as though the stars were waiting patiently for arrival. But the galaxy is not waiting. It is evolving continuously across timescales so vast that civilizations become weather. Brief atmospheric disturbances flickering across one small world before vanishing again into silence. And this is where scale becomes emotionally overwhelming, not because the galaxy is violent, not because it is actively hostile, but because it is so immense that human existence stops feeling central to reality at all. The Milky Way does not resemble a kingdom humanity failed to conquer. It resembles a continent-sized storm system observed briefly by microscopic creatures living on drifting dust. The comforting version of space is mostly an invention of distance, from Earth. The cosmos appears silent and clean. Stars shine steadily. Nebulae glow softly in telescope images. Galaxies drift through darkness with almost dreamlike calm. Even explosions occurring across the universe arrive visually muted by enormous scale and vacuum. The violence becomes abstract, but the real Milky Way is filled with processes that would annihilate biological life instantly. And this matters because the deeper humanity moves into interstellar space, the less protected we become from the ordinary behavior of the galaxy itself. Earth survives because it is sheltered. The atmosphere absorbs harmful radiation. The magnetic field deflects charged particles from the sun. The oceans stabilize temperature. Geological cycles recycle essential chemistry. Gravity holds everything together inside a relatively narrow range of conditions where biology can persist for billions of years. Human beings evolved entirely within this protective envelope, which means our intuition about survivable environments is catastrophically biased. Outside Earth's thin atmosphere, the universe changes character immediately. The vacuum alone is deadly. Without pressure, liquids begin boiling at body temperature. Heat no longer transfers normally. Radiation exposure rises dramatically. Micrometeoroids move at velocities capable of puncturing spacecraft walls. Solar storms can release enormous bursts of energetic particles capable of damaging electronics and biological tissue alike. And this is still inside the sun's local influence. Interstellar space introduces dangers operating across far larger scales. Cosmic rays are among the first. Cosmic rays are not rays in the ordinary sense, but high-energy particles accelerated by violent astrophysical events such as supernovae, neutron stars, and black holes. Some move through the galaxy carrying energies so extreme that individual particles strike with microscopic but significant destructive power. Earth's atmosphere shields us from most of them. Deep space does not. Over long durations, cosmic rays become a slow biological erosion. DNA damage accumulates. Cancer risks rise. Neural tissue may degrade. Electronics experience faults and corruption. Even heavily shielded spacecraft cannot fully eliminate exposure without enormous increases in mass. And mass is already one of the greatest problems in interstellar travel. Every kilogram added for protection requires additional energy for acceleration. Every layer of shielding makes movement harder. The galaxy quietly punishes survival. Then there is dust. Human intuition treats dust as harmless because terrestrial dust moves slowly. But interstellar particles traveling relative to a spacecraft at significant fractions of light speed become devastating. A tiny grain impacting at relativistic velocity releases extraordinary energy, not because the object itself is large, but because motion stores violence. At high enough speeds, even microscopic particles behave like explosive projectiles. Shielding against such impacts across decades or centuries of travel becomes staggeringly difficult. A vessel moving rapidly through interstellar space would essentially fly continuously through a sparse but lethal firing range. And the emptiness itself creates another problem. Human beings psychologically require environments, horizons, weather, day and night, the passage of seasons. Biological life evolved inside dynamic ecosystems filled with sensory variation. Even modern humans living in cities remain connected to cycles shaped by Earth. Deep space offers none of this. No atmosphere, no natural sound, no wind, no open landscapes, only machinery suspended inside endless blackness. This isolation may prove as dangerous as radiation. Long-term psychological confinement already produces measurable stress in astronauts aboard low Earth orbit missions lasting only months. Sleep disruption, sensory deprivation, emotional instability, social tension, and cognitive fatigue all emerge even under relatively controlled conditions with constant communication to Earth. Now imagine a voyage lasting generations. No rescue, no return, no nearby world. Only the awareness that outside the hull extends a darkness so vast that death by exposure would arrive long before help could possibly exist. The galaxy begins resembling an ocean crossed inside a sealed coffin. And what most people never realize is that space itself is also fundamentally radioactive. Not merely near stars, everywhere. The universe is filled with background radiation left over from ancient astrophysical processes and the early universe itself. Supernova remnants flood regions with energetic particles. Pulsars emit intense beams of radiation. X-ray binaries release enormous energy into surrounding space. Even ordinary stars produce flares capable of sterilizing nearby planets under certain conditions. Life survives only within narrow environmental windows. The Milky Way contains countless regions where those windows close permanently. Even gravity becomes dangerous on large scales. Near massive objects, tidal forces distort motion violently. Rogue stars occasionally pass near planetary systems, perturbing comet clouds and destabilizing orbits across millions of years. Black holes wander invisibly through portions of the galaxy. Dense stellar regions increase the probability of catastrophic gravitational encounters. The galaxy is not a calm container holding stars. It is a dynamic gravitational battlefield unfolding slowly across deep time. And then there is the problem of energy itself. Interstellar civilization would require unimaginable power generation merely to survive. Heat management alone becomes extraordinarily difficult in vacuum. On Earth, excess heat dissipates through atmosphere and environment. In space, spacecraft must radiate heat away gradually through exposed surfaces. A highly advanced interstellar vessel could slowly cook itself internally if energy systems became too powerful without adequate thermal control. Even survival obeys thermodynamic constraints. Reality offers no exemptions for intelligence. This is why many physicists and engineers quietly suspect that large-scale galactic colonization may be vastly harder than popular imagination assumes. Not impossible in a strict sense, but hostile in a cumulative sense. Every solution creates another vulnerability. Every layer of protection increases complexity. Every increase in complexity introduces new failure points. And over thousands of years, failure becomes statistically inevitable. Civilization on Earth survives partly because Earth repairs us continuously. Atmosphere renews, water cycles, ecosystems stabilize chemistry. Sunlight arrives freely every morning. Gravity organizes matter naturally into predictable patterns. Interstellar travelers would need to manufacture every condition of survival artificially. Forever. The ship would not simply transport civilization, it would become civilization, a fragile bubble of controlled chemistry drifting through an environment fundamentally indifferent to biology. And the real horror is quieter than destruction, because most of the galaxy is not violently deadly. It is passively incompatible with life. Human beings often imagine cosmic danger dramatically explosions, impacts, black holes tearing ships apart. But reality is colder than that. The universe usually kills slowly, through radiation, isolation, mechanical degradation, system failure, resource exhaustion, entropy accumulating molecule by molecule over immense spans of time. The Milky Way does not need to attack civilizations. It merely waits, and time does the rest. This realization changes the emotional meaning of the night sky. The stars stop appearing like destinations. They begin appearing like isolated survival zones separated by lethal oceans of vacuum and time. Each stellar system becomes a temporary refuge against surrounding hostility, a small circle of warmth inside overwhelming darkness. And somewhere within that darkness, another possibility begins emerging. Perhaps advanced civilizations do exist elsewhere in the galaxy. Perhaps intelligence arises often. But perhaps the distances and dangers between stars naturally isolate every civilization into permanent loneliness before meaningful contact can ever occur. Not because life is rare, but because the Milky Way itself may prevent connection. A galaxy filled with islands that can see one another faintly across the ocean, while remaining forever unreachable. Human beings often assume that survival naturally leads to expansion. A species masters its environment, develops technology, spreads outward, and gradually occupies larger territory. On Earth, nearly every successful civilization followed some version of this pattern. Growth became associated with intelligence itself. But the Milky Way introduces a possibility far stranger. What if advanced civilizations do not expand indefinitely? Because reality quietly prevents them from remaining coherent long enough to do so. This is where the scientific problem becomes deeply unsettling. Because the greatest obstacle to galactic civilization may not be propulsion, or energy, or engineering. It may be time. Not time as humans experience it emotionally, but civilization time. Historical time, the stability time required for societies to survive continuously across thousands, tens of thousands, or even millions of years. Human civilization has never demonstrated anything remotely close to this scale of continuity. The oldest known structures on Earth are already ruins. Languages mutate rapidly across centuries. Political systems fragment. Economies collapse. Religions divide. Knowledge disappears and later re-emerges. Entire populations migrate or vanish due to climate shifts, war, disease, or ecological instability. Even modern technological civilization remains fragile. Electrical grids fail, supply chains fracture, information systems degrade. Social trust fluctuates unpredictably, and all of this occurs on one extraordinarily habitable planet beneath protective atmosphere. Abundant resources, and immediate communication. Now imagine preserving a civilization across interstellar distances. A colony ship travelling for centuries would become a closed historical world. The original mission could easily lose meaning before arrival. Cultural drift would begin almost immediately. New generations born aboard the vessel would inherit myths rather than memories about Earth. Eventually, Earth itself might become psychologically abstract, a legendary origin rather than a living home, and the longer the voyage lasts, the stranger the situation becomes, because every interstellar civilization faces a brutal asymmetry between movement and change. Stars remain relatively stable across immense timescales. Societies do not. A civilization attempting galactic expansion must remain technologically functional for periods vastly longer than recorded human history, while continuously resisting entropy, fragmentation, internal conflict, ecological collapse, and evolutionary change. The odds become difficult to ignore, not because collapse is guaranteed, but because deep time amplifies every weakness. This is where the concept of generation ships begins revealing its hidden implications. Generation ship sounds straightforward in theory. Build a self-sustaining vessel, allow descendants of the original crew to continue the journey. Eventually, after centuries or millennia, the destination is reached. But this assumes something extraordinary about human systems. It assumes continuity as survives isolation. And history suggests otherwise. Civilizations change even under stable conditions on Earth where migration, communication, and ecological support remain available. Entire worldviews transform within a few centuries. Moral systems evolve. Political legitimacy collapses. Collective memory fades rapidly. Now place that instability inside a sealed artificial environment where every ecosystem is manufactured and every failure threatens extinction. A generation ship would not merely transport humans through space. It would carry an evolving civilization through historical isolation deeper than anything humanity has ever experienced. Some descendants might reject the mission entirely. Others might reinterpret it religiously. Social hierarchies could harden unpredictably. Technical knowledge might degrade if educational continuity failed. Resource scarcity could produce conflict. Psychological stress could accumulate across generations born into confinement without any direct experience of planets, open sky, weather, or natural ecosystems. The ship itself could slowly become an enclosed mythology drifting through darkness. And this assumes biological humanity remains unchanged. But the deeper timescales of galactic travel may eventually force another realization. Interstellar expansion might require humanity to stop being human. And because biology evolved for Earth, human bodies are products of one planetary environment with one gravity level, one atmospheric composition, one magnetic field, one evolutionary history. Even small changes in these conditions create physiological stress. Astronauts already experience muscle degradation, bone density loss, immune changes, and neurological effects during relatively short missions. Deep space does not care about biological preference. Over long enough durations, civilizations attempting survival between stars may turn increasingly toward artificial modification, genetic engineering, cybernetic augmentation, machine integration, digital consciousness hypotheses, artificial intelligence systems managing ecosystems more reliably than human cognition. The descendants of interstellar humanity could become unrecognizable to us, not through catastrophe, through adaptation. And here the emotional implications deepen further, because a galaxy-spanning civilization may be impossible not merely physically, but psychologically. Shared identity depends upon shared experience unfolding within manageable communication timescales. Earth functions as a civilization partly because information moves quickly enough to maintain cultural coherence. Even then, fragmentation occurs constantly. Now imagine settlements separated by hundreds or thousands of light years. No real-time conversation, no synchronized politics, no unified economy, no shared historical present. Every colony becomes temporally isolated. A message sent across 1,000 light-years requires a millennium merely to arrive. Entire civilizations could rise and collapse before replies return. Wars would end before communication began. Scientific discoveries would spread slower than biological evolution. The Milky Way fractures continuity naturally, and the farther expansion proceeds, the worse the fragmentation becomes. Eventually, the idea of one galactic civilization may lose meaning entirely. There would only be disconnected pockets of intelligence drifting independently through deep time. And what most people never realize is that the galaxy itself may already contain examples of this silence. The famous Fermi paradox asks a simple question. If intelligent life is common, where is everybody? Enrico Fermi framed the problem casually during a conversation in 1950. But the implications remained profound. The Milky Way is ancient. Many stars are billions of years older than the Sun. If technological civilizations arise frequently and expand aggressively, then in theory the galaxy should already show obvious evidence of their existence. Yet the sky remains silent. No confirmed signals, no visible megastructures, no detected probes, no unmistakable signs of galactic engineering. Many explanations have been proposed. Perhaps intelligent life is rare. Perhaps civilizations self-destruct. Perhaps communication methods are unrecognizable to us. But another possibility is quieter and perhaps more unsettling. Maybe the galaxy itself prevents meaningful expansion? Not absolutely, but effectively. Perhaps civilizations emerge repeatedly across the Milky Way only to remain trapped inside isolated stellar neighborhoods separated by distances too immense for lasting contact or coherent migration. Small islands of awareness floating through darkness, each believing itself potentially alone because communication across galactic scales unfolds too slowly for civilizations to overlap meaningfully in time. A species might flourish for 10,000 years. Another might arise 50,000 light-years away a million years later. Neither would ever know the other existed. The Milky Way may contain countless histories permanently separated by space-time itself. And if this is true, then intelligence does not conquer the galaxy. It flickers briefly within it. Temporary local order against cosmic entropy. Civilizations becoming momentary patterns inside a structure too large for unity and too ancient for permanence. This changes the emotional meaning of progress. Humanity often imagines the future as expansion outward, but perhaps survival itself is the greater achievement. Perhaps remaining alive on one world for geological timescales would already represent extraordinary success, in a universe where most environments destroy complexity faster than it can spread. And somewhere inside this realization, the stars begin looking different once again, not like destinations, not even like unreachable worlds, but like isolated fires burning quietly across impossible distances, each surrounded by enough darkness to keep every other fire forever alone. The Milky Way is not drifting quietly through empty space. It is falling. Everything you have ever known, Earth, the sun, every human being who has lived, every ocean, every city, every memory is currently moving through the galaxy at extraordinary speed, while simultaneously orbiting an invisible center, dominated by gravity so immense that the entire structure bends around it. And yet even this motion is only part of a much larger system, because the galaxy itself is also moving. This is where the scale of reality begins expanding beyond ordinary human emotional capacity. Our solar system orbits the galactic center at roughly 828,000 kilometers per hour, the 828,000 km/h. At that speed, a spacecraft could circle Earth more than 20 times in a single hour. But against galactic distances, this velocity barely matters. The solar system still requires approximately 230 million years to complete one orbit around the Milky Way. One galactic year? The phrase sounds poetic until its implications settle fully into place. A galactic year is so immense that multicellular life on Earth was radically different the last time our planet occupied this region of the galaxy. The continents were arranged differently. Entire branches of evolution had not yet emerged. Mammals were insignificant. Primates did not exist. Human civilization occupies only a tiny fraction of one galactic orbit, and during this motion, the galaxy itself continues rotating through space like a vast gravitational storm system, spanning hundreds of thousands of light-years. No human experience prepares the mind for this, because Earth feels stable. The sky appears fixed. Constellations rise and fall predictably. But stability is an illusion created by short lifespans. Given enough time, everything in the galaxy moves. Stars migrate. Nebulae collapse. Black holes consume matter. Entire stellar populations drift into new configurations. And beneath all of it lies a deeper structure humanity cannot even see directly. Dark matter. Dark matter may compose most of the Milky Way's total mass. Not stars, not planets, not gas clouds. Invisible matter detectable only through gravity. The galaxy rotates too quickly for visible matter alone to hold it together. According to ordinary physics, the outer regions should fly apart, yet they do not. Something unseen surrounds the Milky Way in a vast gravitational halo, extending far beyond the visible disk. Humanity lives embedded inside a structure dominated by matter we still do not understand. This invisible halo stretches outward into enormous darkness, possibly extending more than 1,000,000 light-years from the galactic center. The familiar spiral galaxy visible in artistic renderings may represent only the luminous core of something vastly larger and stranger. The Milky Way resembles an illuminated island floating inside an invisible ocean of gravity, and everything inside it is trapped, including us. This is where the emotional meaning of escape begins changing fundamentally. Most people imagine galactic travel horizontally moving between stars across the visible disk, but the true prison of the Milky Way may be gravitational. Every star, every nebula, every planetary system remains bound to the galaxy by enormous invisible mass. Leaving the Milky Way entirely would require even greater energies than traveling between stars. The escape velocity from our region of the galaxy is staggering. VE equals R2GM. The equation itself appears elegant, but its implications are merciless. Gravity scales with mass, and the Milky Way contains hundreds of billions of stars plus vast quantities of dark matter. The galaxy's total gravitational influence extends far beyond visible boundaries. Escaping it entirely may demand velocities approaching a significant fraction of light speed depending on trajectory and location. Human beings evolved inside a gravitational system nested inside a larger gravitational system, nested inside still larger cosmic structures. The deeper science advances, the more reality resembles layers of confinement. Earth traps us with gravity. The Sun traps Earth. The galaxy traps the Sun. And beyond the Milky Way, even larger structures emerge. The local group contains more than 50 galaxies gravitationally bound together, including Andromeda Galaxy, which is currently moving toward the Milky Way at roughly 110 kilometers per second, not away, toward us. In approximately 4 billion years, the two galaxies will collide, not in the dramatic sense often imagined. Stars are separated by such immense distances that direct stellar collisions remain unlikely, but gravitational disruption will shape both galaxies entirely. Spiral arms will distort, stellar orbits will shift, gas clouds will collapse into waves of star formation. The night sky of future Earth, if Earth still exists, would become filled with enormous rivers of light spanning the heavens, and after hundreds of millions of years of interaction, the two galaxies will merge into a new structure entirely. The Milky Way itself is temporary. Even galaxies die. What most people never realize is that galaxies are not isolated objects floating peacefully through static space. They belong to larger cosmic webs. Gigantic filaments of matter stretch across the observable universe, connecting galaxy clusters over hundreds of millions of light-years. Between these filaments lie enormous cosmic voids where almost nothing exists. Some voids span distances so immense that entire galaxies become rare within them. The universe on its largest scales resembles neural tissue or frost patterns spreading across glass. Immense structure surrounding immense emptiness, and humanity exists inside one tiny spiral galaxy orbiting within one small region of this larger cosmic network. This escalation of scale becomes emotionally destabilizing because each new layer reduces the significance of the previous one. The solar system once felt enormous, then the galaxy dwarfed it. Now even the galaxy begins shrinking against larger cosmic structures. And all of these structures continue evolving across timescales that render civilizations almost invisible. The universe does not merely contain large distances, it contains large durations. The collision between the Milky Way and Andromeda will unfold over periods longer than the entire evolutionary history of complex life on Earth. Entire species could emerge and disappear during the merger process, while the galaxies themselves continued slowly intertwining. Reality operates with terrifying patience, and this patience creates another implication difficult to emotionally process. Humanity may not merely fail to escape the galaxy, we may never truly perceive it coherently at all, because no observer inside the Milky Way can step outside it within a human lifespan. Every map of our galaxy is reconstructed indirectly from measurements, simulations, radio observations, infrared surveys, stellar motion studies, and gravitational modelling. We understand the Milky Way intellectually, but never experientially. The galaxy exceeds the sensory scale of the species attempting to comprehend it, and this disconnect grows worse as larger structures emerge. No human being will ever watch the Milky Way collide with Andromeda unfold naturally in real time. No civilization may survive long enough to witness even tiny fractions of galactic evolution directly. We exist inside systems operating so slowly and across such vast distances that understanding them requires abstraction rather than experience. The cosmos becomes mathematically visible while remaining emotionally unreachable, and somewhere within this realization lies a quieter form of existential isolation. Not merely that humanity is small, but that reality itself unfolds mostly beyond the temporal and spatial limits of human consciousness. The universe is happening on scales we can calculate, while remaining fundamentally too immense to inhabit meaningfully. And against that backdrop, the dream of crossing the galaxy begins transforming into something almost tragic. Tiny biological creatures born during one brief moment of one galactic orbit, imagining escape from structures older than complex life itself, trying to cross an ocean that does not even notice them. There is a strange comfort in human history. Even its disasters feel manageable in retrospect because they occurred inside scales the mind can emotionally contain. Empires rise and collapse within centuries. Languages evolve over generations. Cities disappear beneath forests or sand. Entire civilizations become archaeological layers buried quietly beneath newer ones. Time feels large to us because human life is short, but galactic time destroys this intuition completely. Against the Milky Way, civilization itself begins resembling a temporary atmospheric condition, a brief flicker of organized matter appearing on one planet before dissolving again into geology. And this realization changes the emotional meaning of humanity's future, because most visions of interstellar expansion quietly assume continuity. The same species spreads outward. The same civilization persists. Humanity remains recognizably itself while crossing deep space. But this assumption may be biologically impossible. Human beings today struggle to preserve stable institutions even across centuries. Historical memory erodes rapidly. Nations transform. Technologies become obsolete within decades. Political systems mutate unpredictably under pressure from economics, environment, ideology, and conflict. Now stretch those instabilities across 10,000 years, or 100,000. The timescales required for meaningful galactic movement begin exceeding the continuity span of human identity itself. This is where the human perspective starts collapsing, because the problem is no longer simply about whether ships can survive the journey. It is about whether the travelers remain human by the time they arrive. Consider the scale honestly. At currently achievable speeds, even nearby stars require voyages longer than recorded civilization. More ambitious movement across substantial portions of the galaxy pushes timelines into spans comparable to evolutionary history itself. On Earth, species evolve noticeably across such durations. Climate shifts reshape ecosystems. Continents move, ice ages arrive and vanish. Entire branches of life disappear forever. Yet popular imagination still pictures galactic exploration as an extension of modern civilization. The deeper reality is stranger. A ship traveling for 50,000 years would not carry a civilization. It would become an ecosystem undergoing historical evolution in isolation from Earth. Its language would drift. Its biology might change. Its ethics, culture, and psychology could transform beyond recognition. Even if genetic engineering prevented physical evolution, social evolution would continue relentlessly. Belief systems adapt to environments. Identity reshapes itself around circumstance. A population born entirely inside artificial habitats drifting between stars would not perceive reality the same way terrestrial humans do. Earth itself might eventually feel mythological to them. Not home, a story. And this process may already hint at a larger cosmic truth. Perhaps galactic civilizations do exist, but over deep time they cease resembling unified species and instead fragment into divergent descendants separated by space, history, and adaptation. The Milky Way may contain countless isolated futures branching away from forgotten origins. And if this happens, then humanity's expansion across the galaxy would not preserve humanity. It would dissolve it. This is difficult for the mind to accept because humans naturally equate survival with continuity. We imagine future generations as extensions of ourselves, but history already demonstrates how quickly identity transforms. A modern human transported only a few thousand years into the past would struggle to communicate, survive, or psychologically integrate with ancient societies. Worldviews differ radically even across relatively short historical intervals. Now imagine separation across millions of years and thousands of light years simultaneously. The descendants of Earth could become strangers not merely biologically, but existentially. And perhaps this transformation is unavoidable, because the galaxy exerts selective pressures unlike anything life experienced on Earth. Radiation environments vary, gravity environments vary, resource limitations differ enormously between systems. Artificial habitats may require optimization incompatible with ordinary human biology. Long-duration space populations might gradually modify themselves genetically or cybernetically for efficiency, resilience, or adaptation to non-terrestrial conditions. The farther civilization spreads, the less likely it remains psychologically unified. Eventually, the phrase humanity may stop describing one coherent species at all. Instead, there would be scattered lineages drifting independently through the galaxy, each shaped by local conditions and isolated history. The Milky Way would not contain a civilization. It would contain ruins of shared ancestry, and time deepens the isolation further. Because stars themselves are temporary, stellar evolution ensures that every habitable environment exists only within limited windows. Massive stars die quickly. Smaller stars persist longer but still evolve eventually. Planetary climates shift, orbits destabilize. Radiation conditions change. Entire biospheres collapse under astrophysical processes unfolding across millions or billions of years. Earth itself will not remain habitable forever. Long before the Sun expands into a red giant, increasing solar luminosity will likely sterilize the planet. Oceans may evaporate. Atmospheric chemistry may destabilize. Surface temperatures could rise beyond biological tolerance. The world humanity evolved on possesses an expiration date, and this expiration introduces a subtle emotional pressure beneath all dreams of cosmic expansion. The species must either adapt beyond Earth, or eventually vanish with it. Yet the galaxy offers no welcoming alternative, only difficult refuges separated by lethal distances. This creates a tragic contradiction at the center of human existence. Earth is temporary, but escape may be effectively impossible. And somewhere inside this contradiction lies a deeper source of existential discomfort. Because humans evolve psychologically expecting environments to remain emotionally proportional to survival. Threats existed within scales individuals or societies could respond to directly. Storms, predators, famine, warfare terrible, but comprehensible. The cosmos does not operate at human scale. Galactic processes unfold too slowly for instinct and too massively for intuition. Entire existential threats emerge not as dramatic events, but as inevitabilities embedded into astrophysical time. Stars age, galaxies collide, entropy increases, nothing negotiates, and civilization itself becomes fragile against these enormous durations. What most people never realize is that the greatest challenge of interstellar existence may not be technological at all. It may be meaning. How does a civilization preserve purpose across 50,000 years of darkness between stars? How do generations born aboard artificial worlds maintain emotional connection to destinations they will never personally reach? How do societies endure when every visible star remains unreachable within a lifetime? Human psychology evolved under skies where movement produced results quickly enough to reinforce hope. Interstellar space may sever that relationship completely. Effort becomes detached from outcome. Action detaches from reward. History stretches beyond personal comprehension. The future ceases feeling inhabitable. And this may explain why the galaxy feels emotionally empty even before humanity leaves the solar system. Because the deeper we understand cosmic scale, the more clearly we perceive how brief and local human existence truly is. Civilization begins resembling a temporary warmth generated by fragile biological minds against overwhelming darkness. Not central, not permanent, not even especially durable. Just rare, a small interval of awareness inside a galaxy that has already existed for billions of years before us and will continue long after every human memory disappears. And somewhere inside that silence, another realization quietly emerges. Perhaps the Milky Way does not prevent escape through force. Perhaps it simply operates on scales where identity itself cannot survive the crossing. The deeper astronomy looks into the Milky Way, the less complete the visible galaxy appears. For centuries, human beings assumed that what could be seen was roughly equivalent to what existed. The stars formed the galaxy. Nebulae filled the spaces between them. Darkness represented emptiness. But modern observation slowly revealed a more unsettling reality. Most of the galaxy is invisible. Not metaphorically invisible. Literally. The stars visible in the night sky represent only a small fraction of the Milky Way's total structure. Vast regions remain obscured behind dense clouds of interstellar dust that block visible light entirely. Entire stellar populations hide behind these curtains, detectable only through infrared surveys, radio astronomy, gravitational measurements, and indirect modelling. The galaxy humans emotionally imagine is only the thin illuminated surface of something far larger and stranger. And the farther outward science expands, the more the visible universe itself begins resembling a local illusion. Galactic halo surrounds the luminous disk in an enormous diffuse sphere extending far beyond the familiar spiral arms. Ancient stars orbit there on long trajectories tilted above and below the galactic plane. Globular clusters, dense collections of extremely old stars drift through this halo, like fossils from the early universe. Some of these stars formed over 12 billion years ago. They were already ancient when Earth itself did not yet exist. Human civilization often imagines the cosmos as modern because humanity exists during the current era of the universe. But the Milky Way contains structures so old that they emerged near the dawn of galaxy formation itself. The galaxy is layered with time. Young stars burn inside bright nebulae near the spiral arms. Middle-aged systems like our Sun drift quietly through the disk. Ancient stellar populations orbit the outskirts like remnants from forgotten cosmic epochs. And surrounding all of it lies the unseen mass of dark matter extending outward into enormous gravitational darkness. The Milky Way is not a simple object. It is an ecosystem of timescales, a gravitational archive billions of years deep. And this is where the larger system begins revealing itself. Because galaxies are not isolated islands! They interact continuously. Gravity binds structures together across unimaginable distances, creating slow-motion cosmic relationships unfolding over billions of years. Satellite galaxies orbit the Milky Way. Some are gradually torn apart by tidal forces, their stars stretched into long streams wrapping around the galaxy like scars. Sagittarius Dwarf Galaxy is one such victim. Over immense timescales, the Milky Way is consuming it gravitationally, stripping stars away and incorporating them into its own structure. Galaxies eat smaller galaxies, not violently in human terms, quietly, patiently. Gravity slowly dismantles entire stellar systems across hundreds of millions of years until their stars become indistinguishable from the larger galaxy surrounding them. The Milky Way itself likely grew through countless such mergers. Our galaxy may be partly assembled from the remains of smaller galaxies destroyed long before Earth formed. Even the Sun could contain material originating elsewhere in the cosmos before ancient galactic collisions redistributed matter through the growing Milky Way. Human beings are built from recycled galactic debris, and this recycling never stops. Stars continuously form and die inside the Milky Way. Supernovae enrich interstellar space with heavier elements. Molecular clouds collapse into new stellar systems. Black holes consume matter while ejecting enormous jets of energy into surrounding space. Stellar winds sculpt nebulae across light years. The galaxy behaves less like architecture and more like metabolism. Slow cosmic metabolism unfolding across billions of years. What most people never realize is that even the calm regions of the galaxy remain dynamically unstable over deep time. Stellar encounters gradually alter planetary orbits. Passing stars perturb distant comet reservoirs. Galactic tides stretch gravitational systems subtly but continuously. Nothing remains perfectly secure. Even the solar system may not remain permanently intact across the full lifespan of the galaxy. Simulations suggest planetary orbits can become chaotic over sufficiently long durations. Tiny gravitational interactions accumulate over millions and billions of years. Stability exists mostly because human timescales are short enough to perceive order. The universe appears permanent largely because we do not live long enough to watch it unravel. And beyond the Milky Way, the scale escalates once again. Local group spans roughly 10 million light-years. Within it, galaxies orbit shared gravitational centers slowly and continuously. Beyond the local group lies the Virgo supercluster. Beyond that, larger filaments of matter stretching across the observable universe. Each level reduces the apparent importance of the previous one. The Milky Way once seemed like the universe. Now it appears as one temporary structure among trillions. And yet humanity may never physically leave even this one galaxy. This contradiction becomes psychologically overwhelming because knowledge expands faster than movement. Telescopes reveal structures vastly beyond reach. Mathematics maps realities biological life cannot inhabit directly. Human understanding grows outward indefinitely while human bodies remain trapped within local scales. The mind escapes farther than civilization ever will. And perhaps this imbalance defines modern existence itself. For the first time in Earth's history, one species understands enough astronomy to perceive the true scale of its confinement. Ancient humans feared oceans because they did not know what lay beyond the horizon. Modern humans face the opposite problem. We know, at least partially, we know the stars are unimaginably distant. We know galaxies span impossible scales. We know light itself moves too slowly to unite cosmic structures meaningfully. And still the night sky continues inviting emotional projection, because evolution never prepared the human nervous system for realities this large. The Milky Way looks accessible emotionally while remaining physically unreachable, like seeing mountains across an abyss too wide to cross. And there is another layer to this discomfort. Because the universe is expanding, cosmic expansion means that on sufficiently large scales, galaxies move away from one another as space-time itself stretches. Over billions of years, distant galaxies will recede beyond visibility entirely. Future civilizations may observe a far emptier cosmos than the one humanity currently sees. Eventually, the Milky Way and Andromeda merger remnant may become effectively isolated from the rest of the observable universe. The cosmos itself is slowly separating. Reality contains built-in loneliness, and somewhere inside all these expanding layers, stars, galaxies, clusters, superclusters, cosmic filaments, humanity becomes almost impossibly small. Not metaphorically small, physically small, temporarily small, historically small. A civilization emerging briefly on one planet, orbiting one ordinary star near the outskirts of one spiral galaxy, drifting through an expanding universe filled mostly with darkness. And despite all our technology, mathematics, and imagination, we remain unable to escape even the first layer of this structure. The Milky Way is not merely our location, it is our condition, a vast gravitational environment inside which human history unfolds like a brief electrical signal inside a storm too large to notice it. Silence becomes heavier once distance is understood. Before astronomy revealed the scale of the galaxy, emptiness felt temporary. Unexplored regions implied hidden civilizations, unknown continents, gods, monsters, or future discovery. The unknown carried emotional density because human beings naturally assumed that somewhere beyond the horizon existed another human story. But the Milky Way changes the meaning of silence completely, because now we know how much darkness exists between possible voices, and we know how slowly those voices would travel. The night sky appears crowded from Earth. Thousands of visible stars, a bright river of galactic light stretching across darkness. But this visual richness is deceptive. Most of the galaxy is empty space so vast that even neighbouring stars remain separated by trillions of kilometres of near-total vacuum. The Milky Way does not resemble a city filled with activity. It resembles an archipelago of isolated fires scattered across a frozen ocean. And if intelligent civilizations exist elsewhere in the galaxy, they are likely trapped on their own islands exactly as we are. This possibility transforms the famous search for extraterrestrial life into something emotionally stranger than most people realize. Humanity often imagined first contact dramatically. Signals received, alien probes arriving, communication opening between civilizations across the stars. But real astrophysical distances dissolve this fantasy into something quieter and more tragic. Even if another civilization existed relatively nearby by galactic standards, perhaps 1,000 light-years away, every exchange of information would require millennia. A greeting sent from Earth today would not receive a reply until long after modern civilization had transformed beyond recognition. Conversations become archaeological events. Communication ceases feeling alive. And this assumes both civilizations overlap in time. That may be the hardest condition of all. The Milky Way is ancient. Age of the Milky Way is roughly 13 billion years old. Earth formed only around 4.6 billion years ago. Complex multicellular life appeared much later. Human civilization emerged within the last fraction of a percent of galactic history. The timing is staggeringly narrow. If another intelligent species rose and vanished merely a few million years before humanity appeared, the overlap would be effectively zero. Their cities could have turned to dust before Earth even developed forests. Their signals might have crossed the galaxy long before humans evolved ears capable of hearing them. Civilizations may pass one another in time without ever meeting, like ships drifting silently through fog centuries apart on the same ocean. This is where cosmic isolation deepens beyond physical distance into temporal loneliness. The universe may contain life, possibly abundant life, but space-time itself may prevent meaningful coexistence. The galaxy is simply too large and too old for most civilizations to overlap closely enough to communicate or travel between one another. And even if they do overlap, survival times may remain short compared to galactic durations. Human technological civilization has existed for only a tiny moment. Radio transmissions from Earth have travelled outward for roughly a century, forming a thin, expanding bubble about 100 light-years across, or 100 light-years. Against the Milky Way, this is almost nothing. A microscopic sphere inside a galaxy 100,000 light-years wide. Most stars in the Milky Way have not yet received any evidence humanity exists. The overwhelming majority of the galaxy remains entirely untouched by human presence, and perhaps it always will, because what most people never realize is that detection itself becomes extraordinarily difficult across galactic scales. Radio signals weaken with distance. Background noise interferes. Civilizations may use communication technologies humans cannot recognize. Advanced societies might become quieter rather than louder as efficiency improves. The galaxy could contain intelligence hidden behind physics itself, not intentionally concealed, simply too distant and too separated for mutual awareness. This possibility reshapes the emotional meaning of the night sky. Every visible star may host worlds no human being will ever visit. Some may contain oceans beneath frozen crusts. Others may orbit red dwarf stars for trillions of years. Some planets may have already witnessed the rise and extinction of intelligent species long before Earth formed, and all of it remains unreachable. Not only physically, experientially, human consciousness is confined to one tiny region of space-time while the galaxy unfolds elsewhere beyond perception. This confinement becomes even more haunting when we consider how indifferent the cosmos remains to awareness itself. The Milky Way existed for billions of years before intelligence emerged on Earth. Stars formed and died continuously without observers. Black holes consumed matter silently. Nebulae collapsed into newborn suns. Entire stellar generations rose and vanished without memory. Reality does not require witnesses. Consciousness appears locally, briefly, then disappears again. And this may be happening repeatedly across the galaxy. Small temporary pockets of awareness opening against cosmic darkness before closing forever. Each civilization perhaps believing itself unique because the distances between them remain too immense for reassurance. The silence may not mean emptiness. It may simply mean separation, and the separation is overwhelming. Imagine standing on a shoreline at night while seeing faint campfires scattered across distant islands, too far away for boats, voices, or signals to cross. You know others may exist. You see evidence of them. But the ocean between you is so immense that contact never arrives. Eventually the fires stop feeling comforting. They begin intensifying loneliness. Because visible distance reinforces inaccessibility, the stars create precisely this emotional effect once their true scale becomes understood. Human beings evolved emotionally expecting visibility to imply potential interaction. If we can see something, perhaps we can reach it. The cosmos breaks this instinct completely. We can observe galaxies billions of light years away while remaining unable to leave our own stellar neighborhood meaningfully. Knowledge expands, access does not, and somewhere inside this imbalance lies a profound form of existential grief. Because astronomy reveals not merely the grandeur of the universe, but the probable permanence of isolation within it. Earth begins feeling less like the first step outward, and more like a small illuminated shelter surrounded by distances too vast for companionship. The Milky Way stops resembling a future civilization. It begins resembling a cemetery of unreachable histories, not dead necessarily, just forever separated. And the silence deepens further when one final possibility emerges. Perhaps advanced civilizations eventually stop trying to cross the galaxy at all. Perhaps every sufficiently intelligent species eventually learns the same lesson physics keeps repeating to humanity, that the stars are visible, but not truly accessible, that the universe allows observation far more easily than participation, and that consciousness may spend eternity looking outward across enormous beauty it can never physically inhabit, a species awakening briefly inside one warm system while the larger galaxy continues drifting silently beyond reach. There is a psychological cost to understanding scale. Not immediately. At first, astronomy feels expansive in a comforting way. The universe appears beautiful precisely because it is large. Nebulae glow softly across darkness. Galaxies spiral elegantly through space. The night sky invites wonder because distance remains abstract enough for the mind to romanticize it. But eventually understanding deepens, and beauty changes character. The cosmos stops feeling grand in the human sense. It begins feeling indifferent. Not hostile, not cruel, simply unconcerned with the emotional needs of biological creatures who evolved on one small world. This transition may be one of the most profound shifts modern science has introduced into human consciousness. For most of history, humanity occupied the emotional center of reality. Ancient cosmologies placed Earth near the middle of existence. Even when scientific revolutions displaced our physical centrality, human intuition remained stubbornly anthropocentric. The universe still felt somehow scaled for observation, exploration, and eventual understanding. But the Milky Way quietly erodes this assumption, because once its true dimensions settle into awareness, the galaxy stops behaving like a future homeland. It becomes an environment fundamentally mismatched to human life. And this mismatch is difficult to emotionally absorb because human psychology evolved inside manageable worlds. Our ancestors survived by predicting local patterns, weather changes, animal movement, seasonal cycles, social relationships, immediate threats and opportunities. Evolution rewarded nervous systems capable of operating effectively inside environments measured in kilometers and years, not light years, not galactic epochs. Human consciousness is astonishingly intelligent, yet still profoundly local. This is why the emotional experience of astronomy often produces a strange duality. Intellectually, we celebrate discovery. Emotionally, we confront diminishing centrality. Every major expansion of cosmic understanding has reduced humanity's apparent importance. Earth became one planet among many. The Sun became one ordinary star. The Milky Way became one galaxy among trillions. Even visible matter itself became only a small fraction of total cosmic structure. Science did not merely enlarge the universe, it displaced us continuously within it. And yet something unexpected emerged from this displacement, a quieter form of meaning, because once humanity stops occupying the center of reality, existence itself begins appearing more fragile and improbable than ancient civilizations ever imagined. Life becomes precious precisely because the universe is so vast and so incompatible with it. Earth transforms emotionally under this perspective. Not merely home, anomaly, a thin layer of atmosphere protecting billions of conscious organisms against surrounding vacuum and radiation. A small biosphere suspended inside darkness deep enough to swallow entire civilizations without trace. What most people never realize is how narrow the conditions for human existence truly are. A slightly different orbit, a slightly more violent star, a weaker magnetic field, a destabilized climate, and complex civilization may never have emerged at all. The Milky Way contains billions of stars, yet the overwhelming majority of known environments remain lethal to human biology. The universe does not naturally produce comfort. Earth does, temporarily. This realization changes the emotional meaning of technological ambition. Humanity often imagines itself destined to spread outward indefinitely. But perhaps this belief emerged partly because humans evolved before understanding astrophysics fully. Exploration felt natural when the world appeared open-ended and proportionate to movement. The galaxy is not proportionate to movement. Its scales exceed biological intuition so completely that even light struggles to unify it coherently. And this creates a philosophical tension difficult to resolve. If humanity remains confined largely to one planetary system, does that diminish the significance of civilization? At first glance, perhaps it seems to, but deeper reflection suggests something stranger. Meaning may not depend upon scale at all. The Milky Way does not care whether humanity expands across thousands of stars or survives quietly on one world. Galaxies possess no emotional preference. Physics offers no reward for empire. The cosmos remains equally silent either way. Only conscious beings assign value. And consciousness itself may be among the rarest conditions the universe produces. A civilization existing briefly on one planet could still represent something extraordinary against billions of years of cosmic darkness. Not because humanity is cosmically important, but because awareness itself is unusual. The universe may contain enormous quantities of matter, energy, and structure while producing very little subjective experience. Stars burn without feeling. Black holes distort space-time without memory. Galaxies rotate without thought. Human beings, however briefly, experience the universe consciously. We look outward and recognize scale. We perceive beauty. We fear extinction. We imagine futures larger than ourselves. The Milky Way may never notice this, but the experience remains real to us, and perhaps that is enough. This perspective softens the emotional violence of cosmic insignificance slightly without removing it entirely. Humanity becomes neither central nor meaningless, just temporary, a localized emergence of awareness inside an ancient universe largely indifferent to observation. And maybe this is why the night sky feels simultaneously comforting and unsettling, because it reveals two truths at once. The universe is overwhelmingly vast beyond human comprehension, and somehow, against extraordinary odds, conscious life still appeared within it. The contradiction never fully resolves. The stars inspire awe because they expose scales larger than identity, yet they also intensify intimacy. Every human life unfolds inside one fragile biosphere drifting through immense darkness together. Borders shrink emotionally against astrophysical scale. History itself begins appearing delicate and temporary. The ordinary details of existence, breathing air, hearing rain, standing beneath sunlight acquire unexpected rarity, because the galaxy contains enormous amounts of matter, but very few places where oceans exist, very few places where biology breathes, very few places where consciousness reflects upon the universe at all. And somewhere inside this realization lies a quieter interpretation of humanity's possible confinement. Perhaps the tragedy is not that we may never escape the Milky Way. Perhaps the tragedy would be failing to understand how extraordinary our small refuge already is before time eventually removes it. The cosmos does not promise permanence. Stars die, worlds freeze, galaxies collide. Entropy advances patiently across every scale. Yet for one brief interval inside this immense unfolding, Earth became alive, and on at least one small world, matter learned to look upward into darkness and wonder whether the darkness could ever truly be crossed. Beyond the visible spiral arms of the Milky Way lies a region most people never imagine, not because it is hidden, but because human intuition quietly stops before reaching it. The galaxy appears finite in illustrations, a bright rotating disk surrounded by darkness, structured, contained, something with recognizable boundaries. But the real Milky Way dissolves gradually into immense uncertainty. Stars become sparse, then rarer, then separated by distances so enormous that the galaxy itself begins fading into emptiness. And still the gravitational structure continues farther outward. This is where the final scale revelation begins. Because the visible galaxy is only the beginning of the system trapping us. Stellar halo extends far above and below the galactic disk. Ancient stars orbit there on long chaotic trajectories, some likely captured from smaller galaxies consumed billions of years ago. These stars are separated by extraordinary distances. In some regions, a civilization could travel for centuries without approaching another stellar system closely. Yet even the stellar halo remains embedded inside something larger. The dark matter halo surrounding the Milky Way may stretch outward more than 1 million light-years. 1 million, not kilometers, not astronomical units, light-years. The galaxy humans emotionally imagine occupies only a tiny luminous region inside this far greater invisible structure. And this invisible structure dominates gravitational reality. The sun, Earth, and every star visible in the night sky move inside a prison humanity cannot directly observe. This changes the emotional meaning of the word galaxy completely. The Milky Way is not merely a collection of stars. It is an enormous gravitational environment extending so far into darkness that its true edges become difficult to define precisely, and escaping it may require energies bordering on the absurd. Suppose an advanced civilization somehow mastered near-relativistic travel. Even then, leaving the galaxy entirely would demand journeys lasting immense spans of time. Intergalactic space between major galaxies stretches across millions of light-years of near-total emptiness. The distance to Andromeda Galaxy is roughly 2.5 million light-years. The light entering telescopes from Andromeda tonight began its journey before modern humans existed, before civilization, before agriculture, long before recorded memory, and Andromeda is merely the nearest major galaxy. The observable universe contains perhaps 2 trillion galaxies. Most are separated by incomprehensible gulfs of darkness expanding continuously as space-time itself stretches. This is where human comprehension begins breaking under accumulated scale, because every outward layer reveals not accessibility, but further isolation. The solar system first appeared vast, then the Milky Way dwarfed it, then galaxy clusters dwarfed the Milky Way. Now even galaxies themselves begin looking like scattered particles drifting across expanding cosmic emptiness. And humanity remains confined near the surface of one small planet orbiting one ordinary star. The imbalance between knowledge and capability becomes almost unbearable emotionally. Modern astronomy allows humans to observe structures billions of light years away, while remaining unable to reach even neighbouring stars meaningfully. Consciousness can perceive realities it cannot physically inhabit. The mind outruns the species, and perhaps this is one of the strangest conditions in the universe. A civilization intelligent enough to understand cosmic scale, yet biologically too temporary and physically too fragile to move freely within it. The Milky Way becomes terrifying not because it is uniquely hostile, but because it reveals the probable shape of all large-scale reality. Distance dominates everything. Even light arrives slowly, and there may be no hidden mechanism waiting to rescue intelligence from this truth. Physics repeatedly suggests the same conclusion from different directions. The universe permits awareness, but not mastery, at least not on scales humans dream about. And then there is the future. Not the future of civilization, the future of the cosmos itself. Over unimaginable spans of time, stars will gradually die out across the universe. Star formation will slow as available gas becomes depleted. Galaxies will age. White dwarfs will cool. Black holes will dominate more of cosmic structure. The universe itself appears headed toward increasing darkness. Heat death of the universe describes one leading long-term model of cosmic evolution. If current understanding remains broadly correct, the universe may continue expanding forever, while usable energy becomes increasingly diffuse. Eventually, most stars will disappear. The cosmos will grow colder, dimmer, quieter, not through catastrophe, through exhaustion. Reality itself drifting slowly toward thermal equilibrium over spans so enormous that ordinary language loses meaning describing them. Human beings emerged near the beginning of the stelliferous era, the age when stars actively shine across the cosmos. The universe is still relatively young in some respects. Galaxies remain bright. Heavy elements exist abundantly enough for planets and chemistry. Complex structures continue forming, yet even this fertile cosmic age is temporary. The stars themselves are part of a larger process of gradual decline, and somewhere inside this realization lies perhaps the deepest existential implication of all. Humanity may not merely be trapped inside the Milky Way, life itself may be trapped inside a temporary era of cosmic history. A brief window where complexity can exist before the universe slowly transitions toward deeper darkness. The cosmos begins resembling a vast fire burning down over unimaginable time, and civilization exists only during one flickering interval of light. This perspective transforms the dream of galactic escape into something almost painfully fragile. Human beings imagine expansion because evolution trained organisms to seek survival and territory. But the universe does not resemble a frontier waiting patiently for conquest. It resembles an ancient physical system unfolding according to indifferent laws across scales too immense for biological minds to fully inhabit. The Milky Way was never designed for us. Neither were galaxies. Neither was the universe. We emerged accidentally inside them, temporary consciousness appearing briefly between stellar birth and cosmic decline. And despite all human ambition, all technology, all mathematics, one possibility keeps returning with quiet persistence. Perhaps no civilization truly escapes these scales. Perhaps intelligence everywhere eventually confronts the same horizon. Not a physical wall, a comprehension wall. The realization that the cosmos is so large, so ancient, and so governed by irreversible physical limits that existence becomes fundamentally local. No matter how advanced a species becomes, the stars remain visible, but distance preserves separation, always, and beyond the outer halo of the Milky Way, beyond the last sparse stars drifting through darkness, beyond the invisible gravitational boundary stretching into intergalactic night. The universe continues outward almost without end. Cold, silent, expanding, while one small species on one small world briefly wonders whether escape was ever truly possible at all. After enough scale, the mind begins returning inward, not because the universe becomes smaller, but because human emotion cannot remain expanded forever. There is a quiet exhaustion that follows cosmic understanding, the realization that galaxies drift beyond reach, that civilizations may remain isolated permanently, that even light moves too slowly to unite the structures filling the night sky. Eventually, the imagination stops trying to conquer the cosmos. It simply watches. And from this quieter perspective, Earth begins changing shape emotionally. For most of human history, the planet felt enormous. Oceans divided civilizations for centuries. Mountain ranges isolated entire cultures. The atmosphere above seemed endless. The stars appeared infinitely distant, while Earth itself felt stable and central beneath them. But astronomy reversed this emotional geometry completely. Now the universe feels enormous, and Earth feels small. Not metaphorically small, physically delicate. A thin membrane of life wrapped around cooling rock suspended inside vacuum. Every forest, city, memory, language, war, and human relationship exists within a biosphere so narrow that from sufficient distance it vanishes entirely. The famous photographs taken during the space age reveal this more powerfully than equations ever could. Apollo 8 Earthrise showed Earth emerging above the lunar horizon in silence. Not as territory, not as nations, just a bright, fragile sphere floating alone against blackness. Later came the pale blue Dorostat image captured by Carl Sagan using the distant Voyager 1 spacecraft. Earth appeared smaller than a pixel, a faint point suspended inside scattered sunlight. Everything human had ever happened existed there. Every empire, every ideology, every victory and humiliation, every act of cruelty and love, compressed into something almost invisible. And yet perhaps this is the strange gift hidden inside cosmic insignificance. Because once the illusion of centrality fades, smaller things begin acquiring unexpected weight. Breathing air becomes unusual. Rainfall becomes improbable. Warmth becomes precious. Human life stops feeling cosmically guaranteed. It starts feeling temporary and fragile against surrounding darkness. The Milky Way may be impossible to cross meaningfully, but Earth itself remains astonishing. A world where chemistry became biology, where biology became consciousness, and where consciousness learned enough physics to recognize its own smallness. This alone may be extraordinarily rare. What most people never realize is that the universe appears overwhelmingly empty, not because matter is scarce, but because organized complexity is difficult to sustain. Entropy constantly pulls systems toward disorder. Stars burn through finite fuel. Planetary climates destabilize. Biological species vanish. Civilizations collapse. Order survives locally and temporarily. That is all. And yet temporary things can still matter deeply to the beings experiencing them. Perhaps this is why the night sky feels emotionally contradictory. Astronomy shrinks humanity physically, while enlarging awareness psychologically. We become smaller against cosmic scale, yet more conscious of existence itself. Ancient humans lived beneath the stars without understanding what they were. Modern humans understand vastly more, but the knowledge carries emotional weight our ancestors never faced. We know how large the darkness truly is. We know how unlikely Earth may be. We know the galaxy probably does not care whether humanity survives. And still we continue looking upward, not because we expect comfort, but because consciousness searches naturally for orientation, even inside indifferent reality. The stars become mirrors for existential thought. Not answers, mirrors. And perhaps this is where the dream of escaping the Milky Way changes one final time. At first, escape feels heroic. Then it feels difficult. Then impossible. Eventually it begins feeling unnecessary, not because the cosmos becomes less beautiful, but because meaning may never have depended on crossing the galaxy in the first place. Human civilization emerged from creatures who once feared storms and darkness on open plains. Over time, those same biological minds uncovered relativity, black holes, stellar evolution, cosmic expansion, and the age of galaxies. Matter became aware enough to calculate the structure surrounding it. That alone is extraordinary. Even if humanity never reaches distant stars physically, consciousness has already crossed immense conceptual distances. The species has escaped ignorance, if not gravity. We have seen the larger shape of reality, however incompletely. And perhaps there is dignity in that. The Milky Way may remain uncrossable, but it is no longer invisible. The galaxy exists now not merely around humanity, but inside human thought. A vast structure carried silently within the awareness of a small planetary species drifting through one minor spiral arm. And beyond the atmosphere tonight, the stars continue burning across enormous separations exactly as they did long before human civilization existed. Ancient light still travels patiently through vacuum. Nebulae still collapse into newborn suns. Black holes still bend space-time invisibly. The galaxy continues unfolding without urgency, without intention, without recognition. And on Earth, beneath all that scale, billions of conscious lives continue briefly experiencing warmth, gravity, memory, fear, love, exhaustion, hope. Small local experiences inside a universe almost unimaginably vast. Perhaps that contrast is the closest thing cosmic meaning ever becomes. Not conquest, not escape. Just awareness existing temporarily against overwhelming darkness. The Milky Way does not need humanity in order to continue, but for one brief moment in its long history, a species emerged capable of seeing the galaxy clearly enough to feel both awe and loneliness simultaneously. And perhaps that feeling itself is part of what it means to be alive inside the universe. Tonight, somewhere above Earth, the Milky Way is turning silently. The spiral arms continue their slow orbit around the galactic center. Ancient stars drift through darkness. Invisible halos of dark matter extend far beyond the visible sky. Radiation crosses the void between suns exactly as it has for billions of years, and almost none of it notices us. Human beings will likely spend their entire existence inside one small region of this galaxy. Perhaps forever. The distances are too large. The timescales too immense. The laws of physics too severe. Even light struggles to cross the Milky Way within the lifespan of civilizations. And yet, against all of this scale, something fragile still happened. On one ordinary planet orbiting one ordinary star, matter became alive long enough to ask questions about the darkness surrounding it. That may be the strangest fact in the universe. Not that galaxies exist, not that black holes bend space-time, not that cosmic structures stretch across billions of light years, but that somewhere inside this enormous silence, consciousness briefly appeared, a temporary awareness looking outward from a small warm world. The night sky no longer looks the same once its true scale is understood. The stars stop feeling nearby. The galaxy stops feeling navigable. Space itself becomes colder, older, and more immense than instinct ever prepared us to accept. But perhaps there is also a quieter kind of peace hidden inside that realization, because the universe was never obligated to be emotionally comfortable. It was never designed around human ambition. The Milky Way does not exist as a frontier waiting for conquest. It simply exists. Vast beyond comprehension, ancient beyond memory, and for one brief interval within its long unfolding, humanity became capable of seeing it clearly enough to understand how small we truly are. Not small in a humiliating sense, small in the way fire is small against winter, small in the way consciousness is small against eternity, yet still real, still luminous, still capable of wonder. Far above Earth tonight, ancient starlight continues crossing the galaxy. Some of it began traveling before human civilization existed, some before human beings themselves existed. The light arrives anyway, quietly, patiently, Crossing distances humanity may never survive crossing physically, and beneath that light, on a tiny world hidden inside one minor spiral arm, a civilization briefly imagines escape from the galaxy surrounding it. Perhaps that dream will never come true. Perhaps the Milky Way will remain the largest structure humanity ever inhabits, a vast ocean of stars enclosing every future we will ever know. But even if escape never comes, the galaxy has already given us something else. Perspective, the understanding that existence is larger than instinct, older than mythology, colder than hope, and infinitely more beautiful than certainty. The Milky Way will continue turning long after every human city disappears, long after languages vanish, long after the last memory of our species fades from the universe. The stars will keep burning. Then eventually, even they will begin going dark, one by one, across unimaginable spans of time, until the galaxy itself grows quieter, dimmer, colder, and the universe continues outward into deeper night. But for now, Earth is still warm, the atmosphere still holds, the oceans still move beneath the moon, and somewhere, someone is still looking upward into the darkness, trying to understand the shape of the enormous structure surrounding us all, a small consciousness inside a galaxy too vast to cross, listening to the silence between the stars,